Hey everybody, welcome. This is the last session before the cube crawl, right? So Sachi and I, we are the last session before, I guess, free drinks. Thanks for coming, everybody. Is everybody having a great KubeCon? Woohoo! Yeah, all right. So this session titled Rage Against the Machine, where we are fighting AI complexity with Kubernetes simplicity. And I'll start by just stating the obvious. AI is everywhere. It started off as a novelty toy that we were all having fun with, asking it silly questions, asking it to give us some funny jokes, maybe pirate jokes or Chuck Norris jokes or whatever. But at this point, we're at the period where we're starting to incorporate AI into our daily lives. And we've come to expect AI to give us relevant, factual responses. And many AI-enabled applications already do this, and they do a pretty good job of it. But how can we all do this very easily? Well, that's the goal of this talk, and that's to make LLMs more useful with Kubernetes. And I'm pretty sure we've all experienced this. You ask AI a question, and it gives you a wild answer. And you're like, say what? As awesome as AI is, there are times when you expect it to give you a factual, real information answer. It just comes up short, and it's a little overwhelming, or underwhelming, I should say. And AI is great at making up stuff. It's what it's trained to do. It simply predicts what that next token should be. And sometimes that next sequence of tokens, they're just completely untrue. Take a look at this chat conversation that I had with the base model. I'm asking the model if there's any sessions at KubeCon North America where the session title includes KAITO and RAG. Now, this model has some context and awareness of KubeCon, so it at least knows that it should consult the KubeCon schedule for the information. But the URL is wrong, and the answer is just flat out wrong. So what can we do to give LLMs more context grounded with actual data to keep it from going off the rails? We could do that with fine-tuning, which is to run additional training on the models, but that could be costly, and you might need an ML engineer to actually get it right. And the most efficient way, and especially if you're getting started, is to implement a Retrieval-Augmented Generative, or RAG, pipeline. With this setup, organizations can take knowledge bases, vectorize the data through an embedding model, and store them in a vector store so that when a user makes an LLM request, relevant data is actually retrieved from the vector store. Your original LLM query is then augmented and sent off to the LLM with better information to predict that next token, right? And so it might be easier, cheaper to implement over fine-tuning, but even this diagram looks a little complex, right? So now we have just more infrastructure to deal with. Vector databases, embedding models, retrievers. Yeah, this is not fine. So why does it need to be this hard? I'm a developer. I'm building an AI-enabled application. Just give me an endpoint. And I can point to that and just build my application from there. Sachi, does it really need to be this hard?
No, it actually doesn't need to be this hard. And when working with all of these disjoint frameworks or tools, you can actually pull it together in a declarative mechanism on Kubernetes. So here we're going to talk about the CNCF sandbox project called the Kubernetes AI Toolchain Operator, which we'll call KAITO. We introduced this previously as a Kubernetes native declarative workspaces that really consolidate all of the resources needed to deploy a range of different AI workloads, starting off with inference, really standing up your model for a simple inference service on Kubernetes, backed by GPU-powered node pools, and really pulling in all of the resources that are needed for your deployment itself. It's essentially containerizing your model weights. It's defining the optimal compute to deploy onto, for example, the GPUs, and really standing up that inference service and providing an OpenAI compatible endpoint. Well, working off of that initial inference deployment, then, as we've discussed already, you need to pull in some context. There may be a certain performance point that you reach that you want to pull in more data and make it more context aware, especially when it comes to production applications. So KAITO not only supports inference, but also we pulled in fine-tuning support, kind of containerizing your artifacts along the way. As you do the fine-tuning job, you have your model artifacts, and you can pull them in to inference jobs throughout your AI pipeline. KAITO also supports different serving engines, and probably discussed throughout several sessions during KubeCon, VLLM kind of standing out as that high throughput, high performance serving engine backing KAITO as a default, but also supporting Hugging Face transformers as an alternative. So there's different options to pull in context here for your inference service, for your AI apps, and KAITO also supports tool calling, so pointing to different APIs to get more relevant, up-to-date responses from your inference service, as well as compatibility with MCP servers. And now we're going to be discussing RAG. So RAGEngine here is really simplified via KAITO workspaces. What it's really doing is pulling together that we presented earlier, kind of the disjoint tools and frameworks needed to define your RAG pipeline. So what are they really? Your embedding service, your embedding models essentially representing your text as vector embeddings in numerical format, kind of semantically representing the meaning of the text, and really large-scale documents and text sources that you're working with. Your vector database is storing that information, and in this case, it'd be in-memory remote service for high-speed data transfer, pulling in that information for your inference jobs. Of course, being paired with an inference service, and what's great here with a KAITO RAG workspace is that you'd be able to pull in any OpenAI compatible endpoint. So it could be served via KAITO, it could be served via other tooling that you have in your AI pipeline, and all orchestrated within just 16 lines of YAML.
16?
Yeah, 16.
All right, that's cool.
And it's simplified via the custom resource definitions and the custom resources introduced by the KAITO workspace. So let's actually put this into action. For the fun part, we're going to see this RAGEngine workspace paired together with a few other ways of pulling in context and making an AI app actually context aware in this demo. So their app that we're going to demo here is a simple application, and it's meant to demonstrate KAITO RAGEngine and really help you make sense of the sessions that are in the schedule of KubeCon itself this week. So you can use this application that we'll demo as a game plan for your schedule to optimize which sessions based on topics that you would like to learn more about, or optimize based on the timings that you have available within your schedule.
And I would note that this in no way, shape, or form is the official KubeCon chat application. I think there was like a QR code floating around, so there is one, but we were just having a little fun with this, so. Yeah.
Would you like to go into the high-level architecture?
Yeah, sure. So let me dive into here in the next slide. This obviously is a slide that I did. It doesn't look as pretty as Sachi. See, I do my diagrams with stick figures. But essentially, the application is hosted in a Kubernetes cluster, naturally. And when the user interacts with the chat app, the incoming request comes into an Istio ingress gateway. Now, the UI is just a simple Next.js application, and it sends its inference requests over to an agent service built using Fast API and Microsoft's agent framework. And because we built using Microsoft Agent Framework, we kind of get observability out of the box. So we're piping all the telemetry over to the Grafana open source, looks good to me stack, as well as a Redis service for the chat history. And the actual LLM request is sent through a KAITO gateway, which is built using the Gateway API inference extension with the body-based routing, so that the gateway is model aware, and it can actually route its request to whatever model that we tell it to, right? Just based on the request body. Now, hopefully this flow seems simple enough. Let's move on to see what the implementation actually looks like. Now, what I'm gonna do is I'm gonna pop out of this because I want to do this live and kind of show you. So I am going to really test some of these network demo gods, and I will flip over to here. Hopefully we're good. You can see my slides, and the first thing I'm gonna do is ooh, that is very small. So let me show you this. First thing I'm gonna do is I'm gonna pop over to Headlamp. Hopefully everybody here has heard of Headlamp by now. If not, go to headlamp.dev and go download that. Headlamp, if you didn't know, has a plugin catalog, and you can definitely install a plugin for KAITO. So once you have that installed, just go to your home page and you can connect to your cluster. And once you have this thing installed, you can click on the little KAITO menu option over here, and you can see the workspaces that are already running. So you can see I have a 5.4 mini, and I also have the GPT OS 20B model running. And you can see I have this deployed in an AKS cluster, and so I am running Azure SKUs, and you can see I have 2 different GPU types for that. And you can also check the status, and you can see that the resource is ready, inference is ready, and then if I scroll over, the workspace is ready as well. The plugin also includes a model catalog in which you can just kind of browse through all the models that are supported with KAITO. And you can literally install this by clicking the deploy button. It'll deploy 12 lines of YAML, and you'll have a model inferencing server ready to go. And I'll show you that in a second. You can also chat with the workspace. So I can pick a model, or workspace I should say, and the model, and I can immediately start working with the AI. So I will say hello to the AI because we should always be nice to the AI, right? You never know. And that's basically it. Now, if I flip back over to my slides and I do that, hey, that actually works. What I just demonstrated here is basically the workspace in a nutshell. This is all built using very simple Kubernetes resources, right? So when you go and deploy a workspace custom resource, what you're getting is a service, a deployment, a node, and the pod is scheduled onto that node. This is very simple stuff, right? But what the workspace is doing is it's using the Carpenter API, putting out a node claim, and a brand new GPU node is being provisioned in the cluster, and then the pod gets scheduled on there. So that's a lot of abstraction that's just taken care of for you. And so you should be ready to go in terms of using your application or building with your application right away. Now, the next thing I wanted to show you is how the Gateway API inference extension works. And to do that, I should have just stayed in the slides, but here we go. Basically, we have that concept of a workspace, and you saw that I was interacting with a single workspace. With the Gateway API inference extension in place, I can literally send an additional request property, specify my model name, and the Gateway API has routes where it can evaluate and say, oh, the user wants to talk to the GPT OSS 20B model. Let me route to that inference pool, okay? And so pretty exciting and fun stuff that you can do with this. So let me show you what that looks like. If I slide over here to VS Code, oh, too far. Here we go. So this is the YAML that I was talking about. I mean, it's super short, but you get a whole VLLM instant inference server out the box with that. As far as the HTTP route goes, so this is Gateway API, and it might be a little bit small, so let me just bump that up just a little bit. So basically, it is using Istio, open source Istio on the AKS cluster, and over here you can see that I have a whole bunch of rules in place, right? So for this particular one, if the body request has 5.4 mini instruct, it's gonna route to the 5.4 mini instruct workspace inference pool. And then if it has GPT OSS, it's going to route to that particular inference pool. So let's go see this in action real quick. Again, I have everything pre-provisioned. And so all you got to do is basically, because this is running vLLM as the inference server, it is all OpenAI API compatible. And so all you need to do is, you see that endpoint, it's just the same, right? So it's something that you can do with Azure OpenAI or just OpenAI in general. And so all I'm doing is I'm sending the model, and then I get a request or a response back, and it's a bunch of content. So if I scroll down here, you can see in the actual result, 5.4 mini is indeed the model that it chose. Now, if I send a, that's the wrong IP, if I send a request over to the other model, literally, all I'm doing is same endpoint, same host, different model, okay? And so in this response, you can see here that the GPT OSS 20B was indeed used, okay? So where does that take us? It takes us back to the application diagram, and I'll just fast forward through that. And so now we have an application where chat request comes in, the app sends the inference request, it sends the model name, and then the gateway API just kind of determines where to route that request, okay? So let's just see this in action. I have the app already up and running. I can say, will there be any sessions on KAITO and RAG? This is the awkward silent part where we wait for the LLM to come back. Okay, so it did come back, and it says, yeah, I'm not seeing any session with that in the title. This is obviously not true. KubeCon is not in June, and we are indeed in this session, so it knew nothing about that, right? So let's go fix that. We go fix that by implementing what? RAGEngine, okay? And so with the RAGEngine, basically you deploy a RAGEngine custom resource, and guess what? It deploys the same thing. A service, a deployment, a node comes up, and the pod gets scheduled. But this time the pod is not running any model. It's basically running the code that will do the retrieval and the indexing and all that stuff, right? So as the user, they're going to make the request to the RAGEngine, and then that request kind of flows through, retrieves the documents, and then it sends it over to the inference service. But guess what? I have a workspace just because I wanted to deploy a workspace, right? You don't need a KAITO workspace for that. You can actually point it to any OpenAI compatible inference service. It could be in cluster, out cluster, whatever, but at this point, most people want to use KAITO because they want everything in their cluster, right? And so the application flow changes just a little bit, where the chat request comes into the app, the inference request is made, it flows through the RAG, gets all the documents, and then it comes back through the workspace, right, for the actual inferencing. So let's go take a look at that in action, okay? So if I go over to my VS Code one more time, let's get this out of the way. This is the RAGEngine YAML manifest, and yeah, you're right, 16 lines of YAML. Hey, all right, here we go. So all you got to do is basically specify an instance type in. If you know Azure, you might know that this is not a GPU SKU. The embedding model that is used here, relatively small. You don't always need a GPU for an embedding model, so you can get away with the CPU-based. And here I am actually pointing to the inference service, and so that's basically it, right? So if I go over to this, make a request here, you can see that I already have the schedule index, right? So I already have documents in my index that I just pre-ran because I don't want you folks to wait on that. If I query this actual request endpoint and I say, hey, show me all the documents, you can see that there is actually documents here. And let me show you where I sourced that information from, okay? So we all know this website. This is what we use probably on a daily basis to figure out where we're going to go next, right? And so it has all this schedule information. Well, did you know that, and I need to, there we go. Did you know that you can actually click on one of the Apple or Google Play links? They both go to the same spot. I don't know why they put two links there, but yeah. You can actually download the full event schedule, right? And so it's an ICS file, okay? So once you download that, you can actually, if I flip over here, you can see all the data. So all the event information is there, and it's in text, and it is legible. I can kind of sift through it, but I don't want to look through that. What I can do is I can basically format that ICS file into a JSON format that the KAITO engine needs. And then from there, I can run a workflow to actually index the JSON file. In my case, I just ran a Argo workflow to do that, but you don't need to. And what I can do then is I can then update my application to point to the new, actually add additional config. So I'm going to deploy it now. We're going to do this live. And let me show you the difference in how we got RAG to work here. So if I scroll and I go look for it, here we go. All right, so I'm going to select this for compare. Nope. Nope. Don't do that. Select for compare, and then select for compare was selected. Okay, so let me get this out of the way. So you can see here, my application code didn't really change. All I'm doing is I'm just passing in one more config into my application, which is the RAG index name, and then that kind of helps it route, and this endpoint, right? So I'm just going to a /rag now. And because I have the routing rules in the gateway API, it is able to basically route to the RAG endpoint that we talked about and then back to the workspace. That's literally it. The code, for the most part, stays the same. And so my pod should be ready to go. Let's just make sure. Yep, 52 seconds. OK, so it should be ready to go with the new configuration. So if I jump over here, go back, and then what did I ask it? Will there be any sessions on KAITO and RAG? And hit send. And we awkwardly wait again in silence. This should come back with the better answer for us. So, come on, AI. You know what? I didn't say hello to the AI. That was the problem. I need to greet it. OK, so I'm already seeing good stuff here. Yeah. Sweet. OK, so I see in my answer, and yes, indeed, this is the session. Is the date right? Yep, and that's me and you, right?
Session we're in right now.
Yeah. OK, so if I click the link, hey, I know those people. OK, cool. And then let's see if I scroll down. Oh, there's another KAITO session here. KAITO and KubeFleet. Sponsor keynote. Hey, look at that.
Yeah, upcoming keynote on Thursday.
Hey, there we go. We can learn more about KAITO on Thursday. Look at that. So with that, hopefully you all got to see just how simple and easy it is to implement a RAG engine or a RAG pipeline into your application with almost literally no code changes. So Sachi, you want to take us home from here?
Yeah, thanks, Paul.
Yeah. So just click through. There we go.
As we saw, there were very minimal changes actually needed to the application itself. And KAITO really, so some key takeaways here is that KAITO was able to represent all of the resources, the tools, the standard frameworks, open source frameworks such as Llama Index, FIAs, like vector databases, vector stores, into just a few lines of YAML that are using Kubernetes native constructs. So together, RAG and Inference Gateway were able to pull in context-aware, scalable AI all on Kubernetes, and doing that very efficiently and quickly. So again, using RAG to ground LLMs with your data, regardless of the formatting of the data itself, allows you to actually use lower intensity compute. As we showed here, we didn't even need GPUs for the embedding model part, and really make your AI application more context-aware and be able to repeat this pattern in different different environments, going from test to dev if you have different Kubernetes clusters, and do that much more efficiently than having a lot of disjoint pieces in your RAG pipeline. We used Inference Gateway to route the request to any supported LLM backend. So in this case, we used VLLM with KAITO. Again, you could pull in different OpenAI compatible inference endpoints deployed with other tooling. And this really matters in decoupling your data retrieval from your inference logic, and doing this in a declarative, scalable, and pretty much easy to integrate with your modern application stack.
And the Kubernetes way. Yes. Cool.
So definitely you can go try this yourself. We have the demo repository just here with the QR code. If you'd like to pull in your own context represented in like document sources or large textual databases and build on this application yourself, we would be excited to see what you end up building. We're also pointing to the KAITO RAGEngine docs here, so you can take a look at the API specification, the demo itself, and then also you can join the KAITO CNCF community, as it is a CNCF sandbox project.
Yeah, and I would say the application will be running until I get to my hotel tonight. Now I'm going to take it down. So, but you can try it out at chat.aksrocks and play with it. Just know that it's just a demo app, and it's not as polished. But yes, feel free to play with it, and then go give it a try yourself. Okay.
Yeah, thanks for attending today's session, and definitely share your feedback. We're open to hearing it.
Thanks, Sachi.